Good afternoon, friends. Today, myself, Dr. Kushal Bhattacharya, I should discuss very important topics of fatigue failure and what is endurance strength, what is SN curve. So, in my lecture, I should cover these topics. The first thing we should cover I have discussed the fatigue loading, different types of fatigue loading. Now we should study the design criteria for materials which are susceptible to fatigue loading, and we should go for SN curve, and then we should study for endurance strength of the material. At the end of the topics, we should describe from the SN curve what is endurance strength of the material. Now basically we'll see how material behaves for a fatigue loading, for a completely reversible stress. Now let us see how does it works. Now if you try to imagine this is a specimen which is called an RR more rotating beam fatigue testing machine. Now what is this? Basically this is a fatigue testing specimen. Now what happens as the this thing rotates? This is an electric motor, and this is an electric motor connected with it. So the electric motor causes the specimen to rotate, and there are bearing loads are there, such a way, and revolution counterpart bearing so that the radial load is only applied to the specimen. Now you can increase or decrease the load based on the requirement. Now from here we should draw the SN curve. Now basically we should understand what type of loading basically acting on this model. Now let us see, we have studied what is called a completely reversal stress. Basically if you try to recall my last class, so this is basically called a completely reversal stress. Now basically what is called a completely reversal stress? Now you have studied, this is my time domain, this x-axis represents my time, and this y-axis represent my stress. Now this is condition, this is my stream. So what happens when the time totally fluctuates? So that means total from tension to compression, compression to tension. So this sort of fatigue loading is applied to a specimen. So this is a specimen I have shown. Now how this is applied, how this sort of fatigue loading is applied to a cylindrical specimen. Now if you think that if a specimen is looking like this, now if a specimen is like this, so if a static condition when a load is applied, what basically happens if a static condition, if a load is applied, what basically happens is that this side, if it is this side, should be in compression, and this side, if you go for a plain cylindrical specimen, this is good for understanding. If you go for a plain cylindrical specimen, and that thing for drawing also, if you go for a plain cylindrical specimen, what will happen when you apply a load to it? What basically happens? Basically this portion moves down, and this portion moves down for a static loading. Whenever that suppose the material is not rotating, the specimen is not rotating, you are giving a load to it. So when you are giving a load, what happened? This point is under compression and this point is under tension. So we take this value as A and we take this value as V. So this is static. Now when we rotate this specimen and we keep the load applying, what happens? For time suppose take 1 second, what happens? A is under compression and B is under tension. A is under compression and B is under tension. Now this is the condition. What happened for the next time, for the next sort of second, for the next second 2? The time gap is very less because it is rotating. We are taking for the next second, 2 seconds. What happens after 2 seconds? So B will be under compression and C will be under tension, because this will move upwards. So what is basically happening to A and B? So A and B. So A is first having a tension load, then compression load. B is having a tension load, then compression load. So this basically this cycle repeats over here. Basically this cycle repeats over here. So this is the essence of this is how the load is applied to a system. Now you understand how the load is applied to the system. Now we should plot for an SN curve. Now Now how the SN curve looks like. Now how the SN curve looks like. Now we take a graph. We take a graph like this. Now where the y-axis represents number of cycles, log base 10 number of cycles, and x-axis represent log base n number of cycles, and y-axis represent stress, log base 10 the value of stress, log base 10 value of stress. So if you take this value, what happens? Basically what happens? Now what happens with this load? We apply different types of loadings. We change the loading. So as we change the load, what happens? As we increase more and more. So if you look on the stress strain diagram, so if this is a stress strain diagram for a ductile material, so what happened? We try to load 0.9 times of yield stress. We does not causing the yield stress. For the first time, we does not consider the yield stress. We does not cause the yield stress. That means we are basically doing a what type of loading? We basically are doing a low cycle fatigue. We are basically doing a high cycle fatigue. That means number of N should be more and number of stress develop should and the stress develop also should be less, or the stress develop should, or low stress fatigue, high cycle fatigue or low stress fatigue. So that means we are not going. Now we are applying, starting giving a load at such that the stress develops 0.9, 0.8, 0.8 times of the yield stress, 0.5 times of the yield stress. In this way we apply different load, and the loads could be only applied by changing the weight. So now if you plot a graph, so what happens? Basically what happens when you apply this sort of load after a certain RPM, because it is rotating, after a certain RPM, what happens? Crack generates over the specimen, and the specimen fails and the machine stops. So basically what happens when after a certain RPM, when we are moving this certain RPM, what happens when you apply a high load, that is 0.9 times of yield stress, after a certain RPM, what happens? The crack generates the crack. If you see this diagram, what happens? Crack generates in the specimen, and the material fails. So this thing is repeated. So this thing what happened? So now we note at what RPM there's a digital output system is there. We note after what RPM it fails. Now we applied for different loads, and we plot the graph. So we take the graph 3. We start the graph from 3, then we start 4, then 3, 4, 5, then 6, then 7, then 8. Now 3 means how many that is? 1000. 4 means 10,000. 5 means 1 lakh. So in this way it moves, because it is taking log base 10 in cycle, and the stresses are plotted. Now what happens? We plot the various failure points. Suppose we plot the various failure points by changing the loads. Suppose we get this sort of diagram. Suppose it fails on this with this value of stress. If you give a stress of this value of stress, it fails for this RPM. It fails for this RPM. That is after causing 1000. So in this way we repeated a huge number of experiments, and we got various failure points. So this is all the failure points, because once the specimen is fails, we take another specimen. Once the specimen is fails, we take another specimen. So we take a huge value of failures. We take a huge value of failure points. Now this is we take a huge value of failure points. Now suppose take it for 50 you can take the value for 50 number of specimen or 100 number of specimens. You perform the test at different load conditions. You change the load when you go. That means you are changing the load. Basically, that means what? You are crossing the yield stress also. So in this condition, you are going on loading. So you are causing the yield stress also. So in this way, you applied a various amount of load. So what happens? You get a plot like this. So where the blue points represents the failure points. Now you go for a base fit curve. When you go for a base fit curve, you get a curve like this. Now for ferrous material, you get a curve like this. Now it varies from material to material. The curve nature can vary, but the curve position can vary, but more or less the nature remains same. Now you could see over here, basically what happens at a load of after 10 to the power 6 cycles, you could see an asymptotic nature of the curve. So you could see an asymptotic nature of the curve. So now this curve is basically called as an SN curve. Why basically SN curve? S represents stress and N represents number of cycles. But an important observation you could see over here that after 10 to the power 6 loads, the curve gets an asymptotic nature. Now you see what is the value of this stress. If you plot what is the value of this stress, so we get a value of the stress like this. So this, after this, it indicates that after 10 to the power 6 means huge number of cycles, the failure does not take place. So what does basically indicates? It indicates that that means the failure will not take place. So it has achieved an infinite life. So this portion has achieved an infinite life. The space, that means a material by which the specimen is made. After all, we have done all the experiments of for different specimen made of the same material. So after this life, what happened? The material will not fail. So this is called the material has achieved an infinite life. Now over here, in important understanding, you see what is the stress value after which the material has achieved an infinite life. This stress value is called the endurance strength of the material. This stress value is called the endurance strength of the material. This is called a very important endurance strength of the material. Because it is the maximum value of stress. Please note carefully, it is a maximum value of stress after if given to that specimen, the material will not fail and it will achieve the infinite life. So this is the design criteria for the machine, for the material when it is subjected to fatigue loading. So then yield stress will not be the design criteria, because yield stress is 10 to the power 10. Yield stress is quite, if you design on the basis of yield stress, which is applicable for monotonic load, what happens? The material will fail. But here the material, if you have to design, if you have to take a factor of safety, you have to take a factor of safety based on the endurance strength of the material. Because what happens, the material will never fail at the maximum value of stress. So it will achieve an infinite life. So this is called the endurance strength of the material. I once again telling what is endurance strength of the material. Endurance strength of the material is the maximum value of stress. I have shown as a maximum value of stress for which the material will achieve an infinite life, for which the material has achieved an infinite life. Now this is an important consideration. Now what will happen for a material? If it is loaded up to this point? I have gone into this. So this means this is if you try to remember, if you remember this, we have done this. This is for high cycle fatigue. The loop is like this. But what will happen if the material has gone there, caused the yield strength? Then what will happen? If the material is gone over there and we are applied at this sort of loading. So what happened? We are going for an LCF. This diagram is for LCF, low cycle fatigue. Sorry, this diagram is for this diagram is for high cycle fatigue. This is SN curve for high cycle fatigue. Now what will happen if the material is subjected to for a high stress when it's called the yield stress, or how does SN curve looks like for a low cycle fatigue? Now I am doing that. How the material looks like for a low cycle fatigue. Now same thing, this is n based on number of cycles. Here it will start from 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, and continues. And here it is log base 10n, and here it is stress, log base n stress. Now what happened? We start loading. If you remember, once again I am drawing the diagram. If you start thinking, we are now loading up to this point. We haven't first SN curve we have crossed this, but second SN curve we haven't crossed this. So what happened? The material will move like this and go to the compression phase, then it will again turn, and then it will move. So it moves, it behaves like this. It behaves like this. Now what happened? How does again we plot a number of cycles. Now again we plot what happened? Again we plot a number of cycles, number of failure points. Again we plot a number of failure points. Again we plot a number of failure points. Again we take a number of failure points, and over here a huge load is applied. You can change the load. As you could see. So how does the material behaves? Now the nature completely change. For low cycle fatigue, the curve looks like up to 10 to the power 3, the curve is like this, and then the curve will move like this, and this 10 to the power 6, and it will behave like this. So up to this is the diagram for low cycle fatigue. This is the SN curve for low cycle fatigue, and over here the endurance strength will be the same. It is a strength where it will apply the maximum life. Now what happened? Infinite life. That is an important point. This part is basically achieved, I have told in the previously also, infinite life. And this region is called, this design is based on infinite life design. But this design is based on finite life design. Here if you want to draw any structure where it is loaded above the yield stress or very high over this, that is the material load, that is the material RPM does not cross 10 to the power 6 cycles, you apply a higher load, then you have to, then endurance strength will not be the design criteria. Then what will be the design criteria? Suppose you are drawing a component where you achieve that the failure can take 10 to the power 4 cycles. For that, what should be the design criteria? You just lift perpendicularly to this and perpendicularly shift this. Now, so this stress will be the design criteria for this sort of loading. That is for infinite. This is for finite life. For you want to design a specimen where it can fail after there were 3 cycles. You have a probability you have seen from the previous results. So you just go for this and took this value of stress. So this stress should be the design criteria for load subject to 10 to the power 3 cycles, and this should be the design criteria for load subject to 10 to the power 4 cycles. So this is infinite life, this is finite life design, and this is infinite life design. So that is all about the description of the SN curve, the endurance strength, what I have discussed. So now if you like my lecture, if you like the way of delivering my lecture, put a thumb mark to it, and you can subscribe to my channel for more and more videos. Thank you. Have a good day.